Hello. In just a few minutes, I'm going to explain why this seemingly bizarre exponent rule makes sense. The negative exponent rule I'm thinking of is that when you take a number a and you raise it to a -1 power. Why is that 1 over a? Most people who see this for the first time think, that is bizarre, makes no sense, and they even sometimes get a little upset, think, who made this up? Because I'd like to find out where they live so that I can throw eggs at their door or something like that. But I'm going to explain it to you right now, and you'll see why we actually have to do this, or our lives in a math class would actually be harder, not easier. So the reason why, here's the answer to the question, it's that if this exponent rule isn't true, then we'd need to replace our old rule that a to the m over a to the n equals a to the m minus n with something different. Now, you have learned this rule, presumably, that if you take a to the m and divide by a to the m, that's supposed to be equal to a to the difference between those powers, where you take the top one, subtract off the bottom one. And there are reasons for that you can see in a video that I made. But here's something I'd like you to consider. It would be really inconvenient if, whenever we saw a negative exponent, that we had to use a different rule than this one. If we're going to have this rule, we want it to work all the time, rather than have special rules that work in some cases and other special rules that work in others. This is the only rule. I never want to have to change it. So let's think about how to apply this rule to realize that this has to be true. So, for example, suppose that you had a to the third divided by a to the fourth. A to the third divided by a to the fourth looks like a random example, but I want you to think about it for a moment. A to the third divided by a to the fourth can be evaluated or simplified in two different ways right now. The first way I'm going to put right here, way number one, is just think about what these symbols actually mean and do a little bit of algebra on them. A to the third divided by a to the fourth is equal to, think about what a power means. It means you take the number a and you multiply it by itself that number of times, so 3 of them. What does a to the fourth mean? It means a times a times a times a 4 times. So if you look at that fraction, think about what you know about how to cancel fractions. If you have a over a, that's 1. These cancel. If you have a over a here, that's 1. If you have a over a here, that's 1. Which means the top is just 1, the bottom is just a, and we end up with 1 over a. So a to the third over a to the fourth is really simplified down to 1 over a, which should make good sense to you. But I'd like you to consider a second way to think about how we should simplify this. We should be able to use this rule. And if you use this rule on this fraction, we're supposed to be able to just subtract from the bottom, or from the top exponent, the bottom one. This is supposed to be a to the 3 minus 4. Well, what's 3 minus 4? It's -1. So this becomes a to the -1. And now you see that a to the 3 over a to the fourth is obviously equal to 1 over a. It just is. That's what the symbols mean. But if we have a requirement, and we do, that this rule works all the time, then we must say that this thing is also equal to a to the -1. Which means we've got to say that these two things are the same thing for our rules to continue to work. And that's the reason why. If we didn't make this rule, if we made it something else, then we'd have to come up with other exponent rules, and we'd have to say, oh, in certain cases we don't use this rule. We don't want to do that. It makes life too hard. The final thing I'd like you to just consider after we're done is that we have a definition that a to the third, for example. What does that mean? it means a times a times a 3 times. That's what exponents usually mean, is that you take the number and you raise it, and when you raise it to a power, you multiply by itself that number of times. I want you to notice that doesn't work when you have a negative exponent. You have to throw that out. But these rules continue to work. But don't get fooled into thinking that a to the negative 1 means negative 1a's multiplied together. That's not true. It just means this. Hope that helps.